Hello everyone, and welcome to examples for problem set number 1. I'm Greg Perkins. I will be your host. So here's problem set number 1, and as you can see by these little red circles, these are ones that I'm going to do examples of. So I'm not going to do an example for each and every one, but ones that I've seen students in the past make mistakes on, and I would like to make sure that you get them all right. So this is actually algebra 1, but finding the equation of a line is so important, we use it over and over and over again in calculus. That's where I'm going to start. An example like number 1. So all I did was change the numbers a little bit, but the work is going to be the same. First of all, we need to find the slope. So subtract the two y values, and I'm going to go this direction, y2 minus y1. The direction you go doesn't actually matter as long as you're consistent. So if I go from right to left on the y's, I have to go from right to left on the x's. So on the top, it's going to be 7 minus 9. And on the bottom, it's going to be 5 minus a negative, got ahead of myself there. It's going to be 2 minus a negative 5. Okay, so what does that equal? So on the top, that's going to be negative 2, and on the bottom, this is going to become plus, so it's going to be a 7. And that cannot be reduced, so I can just use negative 2 over 7 as the slope. Now, I'm going to use the point slope formula, which goes y minus y1 equals slope times x minus x1. You can also use the formula y equals mx plus b, and you'll end up with the same answer. But for no particular reason, I'm just going to pick that one for this example. Now it literally says x1 and y1, but if you use x2 and y2, you'll get the same answer. And because I don't want to make a mistake with this negative sign, I'm going to use this. So it's going to go y minus the y value of 7, so this part's done, equals the slope times x minus the x value of 2. Now I just need to simplify. So I'll leave the left side alone for now. On the right side, that's going to be negative 2/7 times x. And when you multiply this negative 2 times that negative 2, that's going to be positive 4 over 7. Now just add 7 to both sides in order to solve for y. So on the left side, it's just going to say y equals. And on the right side, there's going to be negative 2/7 x. And then if you get a common denominator, multiply the bottom by 7, multiply the top by 7. So this will be 49/7 plus 4/7, and 49 plus 4 is 53. And with that, we're already done with number 1. Let's see what else. So on ones like this, you just need to multiply all this out, and then terms will start canceling and simplify it. But for something like this, we need to use the conjugate. For this particular one, the conjugate would be the square root of x plus 5, and this minus would turn to a plus, the square root of 5. So let me show you. I've got one that is very similar. So simplify this. The reason I'm going to use the conjugate is because it gets rid of radicals. And if you look at this, if you could just erase the radicals, it would say x minus y divided by x minus y, that just equals 1. Well, it's not quite as simple as that, but it's sort of like that, as long as you use the conjugate. So the conjugate will be the square root of x plus the square root of y. So you just change the sign in between. So multiply the bottom by square root of x plus the square root of y. And whatever you do to the bottom, also multiply on the top. And I guess I could even put parentheses to emphasize that I'm multiplying. Okay, now on the bottom, when you multiply two conjugates together, it actually simplifies very nicely because there's going to be the first one times the first one. The square root of x times the square root of x is just x. And for the conjugate, the middle terms are going to cancel because this one times this one would be positive square root of xy. And this one times this one would be minus square root of xy, so they cancel. So the only thing left is the last one times the last one, and a square root y times a square root y will just be y, but then it's also going to be a negative. So it's actually going to be minus a y. And on top, I'm just going to copy it down again. Do not multiply out the top. And hopefully you can already see why I do not multiply out the top. And that is because this x minus y and this x minus y cancel. And so all that's left is the square root of x plus the square root of y, which is simpler than the original version. And there's actually lots of ways that we use the conjugate, but this is one of them. Simplify an expression like that. All right, let's see what else. So the next one I circled was the logarithms. So I'll do one similar, but I'm going to change this to a plus instead of a minus. Just change it slightly. So the first thing to do is when you have two logarithms that are being added together, you can change that into one logarithm as long as you multiply the two arguments. So that simplifies the left side. Now if this said minus, then right here I would have division instead of multiplication. And speaking of multiplication, I could actually multiply this out. That would be x squared plus 4x. Okay. Now the next thing is, when it says log for logarithm, that means that the base is 10. And the whole idea of a logarithm is, right here, it's telling you what the exponent is. So that means I have 10 raised to a negative 1 on the right side. And by doing that with my red pen right there, that gets rid of this logarithm. So all that's left is x squared plus 4x. Now, what does that equal? Well, because it's got a negative exponent, that means that it gets inverted, so that is actually 1 over 10. And then, because it has a squared term and a non-squared term and a constant, that's right, we're going to do the quadratic formula. But for one thing, it has to be set equal to 0. So I need to subtract the 1/10 from both sides. And then I could do the quadratic formula. To be honest with you though, I feel like I might mess up the quadratic formula if I'm using fractions. So I'm actually going to clear out the fraction. I'm going to multiply both sides by 10. That step is not necessary, but I would just prefer to clear out the fraction. So it's going to be 10x squared plus 4 times 10, so that's 40x. And then when you multiply this, the 10s are going to cancel. It leaves just minus 1. And on the right, 0 times 10 is still 0. And then do the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And at that point, it looks like it's time to use a calculator. Now, my calculator is not showing up very well, so I'm going to have to adjust, excuse me just a moment, I'm going to have to adjust the contrast. Sorry, you can't see this part real good, but you can see, hopefully see the screen well. So I'll need to Maybe I should even bring it a little bit closer. So it's going to be negative 40 and then plus the square root of 40 squared minus 4 times the a times the c. And now move to the right to get out of the square root, and the whole thing is in parentheses, and the whole thing gets divided by 2 times 10, so that's 20. All right, there's one answer. And now I need to redo that, so I'll just screen grab it and back up. And the quadratic formula has plus or minus, so now make that minus. So there's my two answers, a 0.025 and a negative 4.025. Then readjust. You like how I use my hand to adjust the contrast? Pretty high tech, huh? So one answer was 0.025 and a negative 4.025. And if I stopped right there, it would be minus 1 point because one of my answers is wrong. The wrong one is, well, this original function says log of x, and this x cannot be negative. You can't take log of a negative. So that means that this poor little answer with its negative attitude gets thrown away, and we only have the one answer, positive 0.025. Good job, buddy. Way to be positive. Keep it up. Let's see what else. Page 2 is all about trigonometry. So all of this, problem set 1, is all of it is supposed to be review. Hopefully you've had trigonometry or math analysis that has trigonometry, because these types of problems you should be able to do. And I'm going to do one that sort of summarizes the whole thing. So it's sort of like this one, the hardest one. I mean the funnest one. Okay, here we go. So in order to solve, I need to isolate the sign. So I'll have to get rid of the square, I'll have to get rid of the 5, and I have to get rid of the negative 1. The negative 1 goes first, so add 1 to both sides. So now it equals positive 1. Next, divide both sides by 5. So when you divide by 5, it now says sine squared equals 1/5. Then get rid of the square by taking the square root. And when you take the square root, don't forget that there's two answers, plus or minus the square root of 1/5. Now, in the end, I'm going to actually find 4 answers. So 2 answers will come from when I put sine of x equal to the positive square root of 1/5. And since the square root of 1 is 1, I actually could rewrite it as 1 over the square root of 5. There's the other possibility where sine of x is equal to the negative 1 over square root of 5. Now, working on this one, take the sine inverse of both sides. So x will equal sine inverse of 1 over the square root of 5. And again, I'm going to need to use the calculator. So that means one thing I need to do is turn it on and then adjust the contrast and just go, what's sine inverse of 1 divided by the square root of 5. And by the way, if you don't put the last parenthesis, the calculator understands that, and it gives me the answer 0.464. And when I do the sine inverse of the negative 1 divided by square root of 5, turns out that it's a negative 0.464. So this one gave me a positive 0.464. And when I did sine inverse on this one, it gave me a negative 0.464. So far, we only have one of the four answers, because if you look at this, it's saying you're supposed to be giving positive answers and all answers between 0 and 2 pi. So this is going to be one of the answers. This at the end is not, but it's going to help us find two of the other answers. Now what I do is keep these separate. And basically, this is saying, look at the sine graph. So the sine graph looks like this from 0 to 2 pi. Right here is 2 pi. Right here is pi. And it was saying, when you look at the sine graph, when does it equal? A 1 over square root of 5. So let's say on the y-axis, right here is 1 over the square root of 5. And then if you make a horizontal line go straight across, there's actually two answers. 1, 2. So the calculator gives you the one that's closest to the x-axis. So that is the 0.464. Any other answers you have to find yourself. Well, this answer is actually to the left of pi. And because the graph is symmetric, if this is a gap of 0.464, that means this is a gap of 0.464. So that means that this answer is to the left of pi by 0.464. So that means that it's pi minus 0.464. So let me just do that off on this side so I don't have to adjust the contrast again. Pi minus 0.464 is a 2.678. Oh, I like how they put that in order. 6, 7, 8. Hey, why did 6, 7, 8? Whew. Look at that, we're almost done. Now what about this one? So again, if you look at this part, it's saying, look at the sine graph from 0 to 2 pi. And now it's equal to a negative 1 over the square root of 5. Then get a nice trusty red pen and make a horizontal line go straight across. And then you'll see that there's two answers. One is just a little bit bigger than pi, and one is just a little bit smaller than 2 pi. Well, like I said, the calculator likes to give you the answer closest to the origin. So what the calculator did is it said, well, if I go this way and I extend your red line out this way, then I find the answer negative 0.464. So that is a solution, but I was asking for these two positive solutions over here. So we could use the 464, we just don't use the negative. So the 464 is saying this gap is 0.464, which means that this gap is also, and this gap is also. So that means that this solution is to the right of pi. So it's going to be pi plus 0.464. And this one is to the left of 2 pi, so it's going to be 2 pi minus 0.464. Using these little graphs really helps a lot. So let's see, what are the final answers? So I need pi plus 0.464. Again, I'll just do that off to the side real quick. And that is a 3.606. And now do this one, 2 pi minus a 0.464. And that is 5.819. And there's 4 solutions from 0 to 2 pi.